I know I'm with the hardcore bioeconomy people that are left at 5:10 at the end of a long day. I've taken a lot of notes because I think partly what Wes wanted me to do is summarize some of the things we talked about, but fortunate for me, most all of it is already included in our heart food system. So I'm going to share that. My name is Mark Buehrer. This topic is recycling food, crop, and animal waste for a more secure food future. I started a company. I'm a professional engineer. I started 2020 Engineering in 1995. I've done hundreds of engineering projects around the world, mostly green building projects. I've been a transportation engineer, water engineer, wastewater engineer, geotech, soils engineer, geology. I've pretty much have a lot of experience with a lot of things. I helped develop LEED, so I got really into the green building movement and developed a lot of projects using sustainable building methods, and then I helped develop the Living Building Challenge. And as we did that, that's the projects that we do: net zero energy, net zero water, net zero waste, and then we added urban agriculture to it. Okay, so urban agriculture, I've been adding that into our projects, for the last, 14, 15 years. Well, when COVID hit, I had time because as a consultant engineer, you get to design things, but you just hope somebody that they hire builds them the way you want them, and then you hope they hire somebody that can operate them. So we started Hard Foods as design, build, operate, so we can stay involved with building it right, delivering it right, and staying involved with the operation of it. So that's kind of the background. Our philosophy was environmental, economical, and simple. And when you use that philosophy, you come up with solutions that are nature-based. And those are all biological type systems, microbial, and with a focus on health. So the other thing that I've learned over the years is that the most economical and simplest way to design these systems that everybody seems to agree on, whether it's water systems, water reuse systems, food systems, if you can do them on a small scale, decentralized, you eliminate the transportation. The transportation footprint of what we do impacts the cost of everything. And talking about food, that's a big part of the food cost is the transportation. So that's a little introduction of that. The other theme that's really catching on, and I'm talking about this in other places, is the food, energy, water nexus. And I think that's been talked about, circular economy and closed-loop systems. What is the most critical energy stored on Earth? We can survive without oil, coal, gas, and wood, but how long can we live without food? So how is the energy stored in food expressed? Calories, energy needed to raise temperature of 1 gram of water by 1 degree Celsius. So the more energy in the food waste that we have, the more energy we can get out of it. This is what struck me a few years ago when I started thinking about what can I do to address this issue. And worldwide, you can get this from United Nations and other places. 1/3 of the world, 1/3 of food is wasted. And the number is 1.3 billion tons. And my wife is a co-founder with me, and it's one of those numbers. It's like, how do you put your head around what 1.3 billion tons is? So she came up with this idea. She found out the largest ship is 230,000 tons. It would be 1.3 billion tons a year of food waste is equal to 6,000 of those ships. This is how much food waste, it's like you can't even conceive that this is what we're doing on the earth with all the effort we're taking to grow food and ship it. This relates now to the environmental footprint. Worldwide greenhouse gas sources, the global food system contributes about 1/3 of the total when you consider the indirect emissions. You can see the green area there, 22% just dedicated directly to the production of food. But when you ship it, you're shipping it, you're storing it, you're processing it, refrigerating it, that adds another 12 or so percent to the overall 1/3 energy. So when I start thinking about the carbon, most of that carbon comes, is from the energy. Okay, energy costs money to use it. So if we can get to the systems that have less energy footprint, we're just going to reduce the carbon footprint as well. So you kind of get that win-win between the economics and the environment if you think of it that way. This is the other piece, better farm-to-fork economy. So worldwide, a farmer only gets about 27% of the price paid at the grocery store, you could say. So there's a lot of money, soaked up there in transportation and storage and markups and grocery store market, all that sort of thing. So when we can grow food locally, right, where the food waste is, we can sell that right back and have a much really good price for the food. Our goal is to have really low-cost, healthy food. So circular economy. So if our goal is to have 30% of the produce grown in a local community, and these are farms owned by the community, by the way. We're not owning these all. But 30% of the food, that's 30% of the money that's going in there. So you're keeping that money back in your own community as well. I've spoken at Big Ag conferences as well. And this is just like a big visual of the food flow. So you got all these nutrients coming into your community from all over the world, shipped thousands of miles away. That's nutrients, energy, water, shipped to these food hubs. And in the United States, I think of a food hub as the local grocery store with restaurants, maybe serving a community of 5,000 to 20,000 people. A large percent of that food waste then ends up as waste. We've heard you pay to get rid of your waste. That goes whether it's to landfills or even composting, you're still paying for it. The idea of closing that loop is instead of it being a waste, you send it back out either to the local farms, the nutrient flow, the orange represents the nutrient flow, or the urban farm is right there where the waste is, totally eliminating the transportation. So it could be in the parking lot of the local grocery store area, or at the hospital, or the school, the campuses, Eliminating the transportation is really a big goal of what we're trying to do here. So the community food, animal, and crop waste producers, you got the farms, food processors, grocery stores, restaurants, hospitals, schools, and university campuses, farmers markets, residents. Everything we do is modular. I want to deliver a fully functional system that we've built in a shop, set it up, and be up and running in less than a week. And you can do that because you've already tested it before you shipped it out. And you can even have your starts of your plants ready, so when you get there, you've already got them planted that week and growing. Renewable biogas, renewable clean energy. Of course, we can produce electricity. We can have a side business of charging our own vehicles, because if you need to have some delivery, you might have your own electric little truck there. Heating, cooling, carbon capture is another big piece of this, and carbon reuses, because we put that carbon back into our cycle. The other thing, which is an IP of ours, is taking the digestate and from an anaerobic state to an aerobic, so it's a robust biological live culture fertilizer, seeded with all the best select plant-favored microbes and things that will help the plants and grow a nice biomass around the roots of the plants to transfer the fertilizers and nutrients. Net zero design, this kind of comes from our building industry thing, but we've used that same idea into the heart foods, which is the energy, nutrients, water, and carbon in the food, animal, and crop waste is processed by the Heart Foods BioLoop Tech system, a trademark we got, in our closed loop design. So that's a goal of net zero design, net zero waste, net zero energy, net zero water, and net zero carbon. So as we're designing things, that's just in the back of our mind all the time. We want to make everything as efficient as possible. The BioLoop Tech system recycles energy, nutrients, water, and carbon from food, animal, and crop waste to produce the clean water, renewable energy, the clean power, capture the CO2, and create a robust biological live culture fertilizer we call BioBrew. And I'll talk a little bit more about this system coming up here. But why do I want to do this? It's you know, as an engineer, I like to figure out things and come up with solutions and use new technologies that I see in one industry and pull them into our system. But ultimately, you know, what's on my heart is to have food as medicine. So in your local communities, and especially like food deserts and other places that really need to have healthy, fresh food at a low price, is to create the food right there and keep it nutrient dense and healthy, organic. And so that's where I'm heading, you know, with what all the technology we have can do is to have that final ability. As I've been working and talking at conferences on this, you know, the light green one on the left, we started with just this idea of food waste to food, but you can apply this to those other industries, including modern regenerative agriculture, controlled environment agriculture. That's a lot of food being produced now in greenhouses. Food processing and manufacturing, I've connected with Nestle. You know, they've got 143 countries. They've got food waste everywhere. They're trying to figure out what to do with it. And they can turn their food waste back into a profit center, reuse it. And then also involved with controlled environmental aquaculture, recirculating systems with tilapia and other fish that can be grown. So the BioLoop Tech System, we're looking at food, animal, crop waste. One of the problems, of course, that we've heard all about is what to do with this waste, well, you're paying for it. So there's a cost of handling. Well, we want to turn that around and look at it as a profit center. So if you look at it, you know, from an economical standpoint, it makes a lot of sense that we take that water, nutrients, energy, and turn it into a profit center. The fertilizers have got value, the water's got value, clean power, heat, and the liquid grade CO2. Pieces of it real quick. I put the fuel cell because now we're in the age where the fuel cells come along that it's reliable and efficient, and we've got some really good partners on the fuel cell system. So you take the food waste through an anaerobic digester. This is very simple systems that have been around. We've got some partners that are really good at it. We've got some ways to tweak the digestate to increase the methane percentage in the biogas. And then we run that through a fuel cell system. Methane is CH4. You know, you split the hydrogen off of the carbon. The hydrogen goes through the fuel cell. We capture the CO2. So the fuel cell creates the electricity and the heat. And of course, heat you can convert to cooling if you need the cooling aspect of it. And all those can be put into those different industries. The food grade piece is really critical because we want the CO2 for enriching the grow rooms. You get more production. But this also leads us to a system that's clean energy because we have zero emissions. And so we've taken the waste and already converted it without any emissions. So the energy, so that checks a lot of boxes on the environmental side of the energy system. Water is not a whole lot of water, but we'll take the water and we'll supplement that into our system. It's pure water that comes off the fuel cell system. And then this piece is the water and nutrients. So that's the digestate that's been talked about today. You get the liquids. And it's very valuable food waste because we're very selective on what materials we bring in. Food waste has all the microbes or micronutrients, and not just the NPK, but it comes from all the soils from all over the world that have been shipped to your place. So now you've got what ends up being, you know, a perfect fertilizer blend because it's already coming from the food waste that was grown. And so we take that, because you start with the digester, which is anaerobic without oxygen, and then we have a kind of a two-step process where we capture all the nitrogen and enhance it through controlling the pH and some other things and additives with our select microbes that the plants love. And then we take that, and it can be diluted way down when you run hydroponics. So one of our goals I had was to show that we could grow food, organic fertilizer. So the nutrient value, if you took your produced food, tomato, whatever it is that you're growing, that it would have the same or better nutrients in that soil that's grown in organic soil. So that was kind of the goal of ours, is to do it that way, and I'm sure we can do that because we've mimicked what the conditions are in the soil. with adding the microbial and the life to it. And we can you can see the top there, the natural gas. We can blend in natural gas, so we can always have a reliable source. And so we've already got that kind of figured out, how we can take, because you have a little bit a different quality of the gas from the biological source, but it can all be blended and run through the fuel cell, and then it can be applied to other things besides food, including buildings and data centers and everything. We can apply this to soils, so this is the regenerative agriculture, kind of modern agriculture applications. It's putting the life back in the soil. So we got this live culture biological fertilizer that can then be applied with existing technologies that are out there being used to irrigate and fertilize farm fields. And, when I started this, hydroponics was kind of a big thing, but as you know, most hydroponic grown food is grown with chemicals, fertilizers, and we wanted to do it with organic, make it as healthy as possible. And that's all possible with our blends, and we can do berries and greens and herbs. We've got over 100 different types of plants that we can grow. So we have partners on that. And then the technologies that have come along, and that includes ways to scan your crops with drones and optics and everything else, and using AI to crunch all the data so that you can make sense of how your settings of your grow rooms were done and how much production you got, so you can, tweak, be recommended, maybe change your room temperature or your pH, and that's there could be a lot of engineers and scientists that are going to love kind of studying this stuff. And imagine as if we get dozens of these farms and hundreds of these farms all over the world, we can just keep making these systems better and better. There we are. I don't know what time I have. 2 minutes. Okay. So this is we call it the mini farm. I've got examples in the back of some other renderings of the greenhouses and stuff. I knew I had a limited amount of time to put this all together. And if you want to contact me, because we're looking for partners, you might want to be a customer. We stay involved with the operation all the time, and we have the PhDs and the smart people on our team. So we want to make sure, if you're in a community or a food desert or wherever these operations are, that the systems will always run reliably. And if there's ever a need to switch production, any questions, we'll always be on there. We're supplying the right additives to it, so it's kind of like a licensing agreement. Some people might refer to it as a franchise, but the point is it's kind of like an HVAC system or something where we deliver the whole package to our customers, but we stay involved as a partner, so they always know things will always operate right. This is 5 systems. Like I say, this could fit in this would be perfect for grocery stores. These are 20-foot containers. A typical parking stall is 20 feet. This has all the components in it. This will be our first prototype. We're in our second round of investment now too. So we raised $250,000 a few years ago, piloted all of our critical IP components of the biological systems and whatnot. So I want to thank Chris for recommending me to be here. And I wanted to plug up my friend Roger back there too, because when we talk about efficiencies and making these things run as efficient as possible and low cost, he's got a patent on the development of a very low energy carbon capture system. It's designed after a leaf. It's called the tension film CO2 capture, a non-thermal interfacial pathway that is nearly energy free. So that just is another piece of pie. Now we've got a valid CO2 capture system on our piece, but it does take a little energy to run it. So we'll always be looking at ways to make our system more efficient, and that technologies keep improving, and so we want to keep it flexible. So my time just ran out here, so Thank you, and I really learned a lot this week, or today. I appreciate, Wes, you putting this together. And there's only a few of us out here, right, that think about these things, and I think we can all work together to really grow this whole bioeconomy thing that you guys have put together here. So thank you for letting me do this.